paper, it's a joint paper with JOAC, and much of what I have to say today can be summarised in this picture. If we look at this picture, here's a week's worth of food for a Norwegian family, and similarly for a family in Chad. And we see four things from this picture. First of all, seems to be lots more food in Norway than Chad. Second of all, not only is the volume of food, there seems to be more items of food, more diversity of food there. Next thing we see is that the share of income devoted to food in Chad is about 50%. It's only 10 and a bit % in Norway. And the final thing that we see is if we look at these items of food carefully, we'll see that somehow there's something fundamentally different about them. And that fundamental difference about them is going to be discussed subsequently, and something perhaps revealed. This paper is about diversity of the diet, diversity of food budgets. And it's usually the case that diversity is a good thing, that diversity brings benefits with it, and usually more diverse consumption bundles represent higher utility than specialised ones, and usually more diversified diets bring nutritional advantages too. And diversity also figures prominently in popular discussions, as summarised by these aphorisms. Variety is the spice of life. Don't put all your eggs in one basket. Change is as good as a holiday. Diversity is our strength. Two heads are better than one. The wisdom of crowds. All work and no play makes Jack a dull boy. And maybe the law of large numbers. Also, diversity figures in airport bestsellers. Here's a bestseller, a recent bestseller entitled "Driven by Diversity: How Great Companies Fuel Innovation Through Diversity" by David Livermore. And David Livermore is a self-declared thought leader in cultural intelligence, known as CQ for short, and global leadership. Okay, how can we measure diversity? A simple way of doing it is just to count up the number of food items being consumed by the household. So we could have a count index. We could just tabulate N sub H, the number of items consumed by household H over a certain period of time. It's not such a great measure. A better measure is to recognise that some items are more important in the budget than the others. So a better approach is to use how much we spend on item I as a fraction of the total budget. That's WI, the budget share. And these budget shares, they play a prominent role in what I have to say. So one way of using these budget shares to measure diversity is the Herfindahl index, the sum of the squared shares, that's H. And the Berry index is just a transform of H, it's 1 minus H. So if we get a higher value of B, we get more diet diversity, and we get less dispersion amongst the shares, a more even spread of, say, total food consumption amongst the individual elements. Now, this is related to Engels' law. Engels' law, as income rises, the percentage of income devoted to food drops off. And Engels' law, it's one of the most important laws in economics, and because I'm sure there are some students here, I have a question for the students. Give me another important law in economics. Second? No? Don't be shy. Give it a try. Yeah? Yeah, diminishing returns, that'll do. Yeah, diminishing returns to the variable factor, or the law of demand curve slope down, or the quantity theory of money, or purchasing power parity. All of these things are important laws in economics. It's not really understood what's the link between Engels' law and diversity. And that's what I'm going to talk about a bit. But before I do that, here's my all-time favourite picture in economics. On the vertical axis, we've got the food share, the share of food, the share of the budget devoted to food. So that family in Chad, they're up here somewhere. They devote a little bit more than 50% of the budget to food, and the Norwegians are down here. So on the horizontal axis, we've got income on a geometric scale, and there's 155 points here, one for each of 155 countries in 2011 from the ICP, the International Comparison Project database. And this is truly a spectacular picture, because we don't make any adjustments to these food shares other than controlling for income. And it's remarkable how close these 155 points lie to this downward sloping straight line. There are a couple of outlying observations here. It's not perfect, but still pretty impressive picture. Now, let's consider this. Here's an equation for that straight line. We've got the share of commodity I, WI. It's a linear function, the log of income. So beta I is the income slope. Now this equation here, that's the income part of the almost ideal model of Deaton and Milbaugh that I'm sure at least some of you have come across. And these slope coefficients up here, the betas, are very, very important in all of this, because these slope coefficients code whether or not the commodity is a necessity or a luxury. If the budget share falls with the income, then this slope coefficient is negative, and that's a necessity. For positive slope coefficients, the commodity is a luxury, because when the income goes up, the budget share goes up. That's a luxury. So the sign of these betas tell us whether or not it's a luxury or a necessity, whether or not eta, the income elasticity, is greater than 1 or less than 1. So if that slope coefficient is 0, the income elasticity is 1, so that's sometimes known as homotheticity, whereby the budget shares are constant with respect to income. Okay, now I have a short digression on the A model, the AID model, almost ideal model, and Deaton last year won the Nobel Prize for his analysis of consumption, poverty and welfare. So here's the whole AID model. First thing here is we've got the income part that we talked about before. P star is a deflator of income. It translates nominal income into real income, and here's the price term of that model. And the Economist magazine reported Deaton's Nobel Prize last year by saying in earlier models demand was assumed to increase in lockstep with income regardless of how rich the person was. The new approach allowed for different responses according to the level of income, so that a 1% pay boost might raise porridge demand by 2% for a pauper, but only 0.1% for a prince. That sounds perfectly reasonable, so let's tabulate this. So here we've got the pauper. When the pauper's income rises by 1, porridge consumption of this gentleman increases by 2%. So the pauper's got an income elasticity demand for porridge, according to that quote, of 2, whereas if we do the same calculation for the prince, the income elasticity falls to 0.1. So that's perfectly reasonable that income elasticities fall like that with income. So far, so good. But, however, the error that the economist has made is that this is impossible in the AIDS model. This cannot happen in the AIDS model because the income elasticity in AIDS is 1 plus beta I on WI. Beta's a fixed constant. This thing varies. That cannot change from being greater than 1 to less than 1. So AIDS rules out this switch of commodities from a luxury to a necessity, even although this is perfectly reasonable behaviour of those income elasticities. So AIDS isn't perfect. Incidentally, this drop in the income elasticities like this from 2 to 0.1 as income rises, that's reasonable, but it's opposite to the direction predicted by other models, such as linear expenditure system and Rotterdam model, that have constant marginal shares. So maybe that's what the economist is talking about when they talk about older models have consumption moving in lockstep with income. So that's a little digression on the AID model. Back to measuring diversity and Engels. Remember the Barry index of diversity, 1 minus the sum of squared budget shares. If we combine this with the Engels curves, that thing there, and do a few simplifications and work it out, it turns out this Barry index is quadratic in the log of income. And these coefficients on the quadratic, capital Phi, it's related to alpha and beta from up here, as is the coefficient on the square of log of income, capital gamma. So in particular, if those betas are all equal to 0 up here, if we've got income elasticities all equal to 1, then these coefficients Phi and gamma are 0, so Barry is a constant. So nothing happens to diversity as income rises if we've got unitary income elasticities, and that makes sense. And the point is more general. So the Barry index is independent of income if those betas are equal to 0, but more generally, because Engels' law tells us that we have non-unitary income elasticities, food is less than 1, other goods on average have an income elasticity greater than 1, we could conclude that Engels' law implies that diversity increases with income. Diversity of the consumption basket increases with income. How does this all work in practice? Let's look at these data from the 2011 ICP, International Consumption Comparison, that gives us PPP prices and expenditures on a large number of commodities. We're going to use 31 items of food consumption in 155 countries. Here's the structure of our data. Let's first of all start with total consumption, and we can break it into food and non-food. On average, food accounts for 27% of total consumption. We then break food into these 1, 2, 3, 4, 5, 6, 7 groups, and here's on average bread and cereals account for 17% of food consumption. And then the bread and cereals group is broken into rice, other cereals, bread, other bakery, pasta. And here this tells us that on average, averaging over those 155 countries, rice accounts for 22% of bread and cereals consumption. And then each of these other groups is broken down into several individual items to give us the 31 food items in total. Yeah?
Is that average by average of the countries or average over the population of all those countries?
It's the latter, average over all countries.
Okay.
So lying behind that, we've got huge diversity of those averages, but it's the global average.
Right. Okay, that's what I was going to hear.
So that, in fact, it's a good question because I can illustrate something about the diversity that lies behind these averages. Let's take this group called bread and cereals, made up of those 5 items, and let's split it into rich countries, the upper quartile, upper income quartile, and poor countries. In rich countries, they spend about 10% of bread and cereals on rice. That increases to 38% in poor countries, whereas bread, we've got almost the mirror image. Bread absorbs 38% in rich, 15% in poor countries. So there is huge dispersion across countries. Here's another way, a better way of measuring dispersion. Yeah?
Yeah, Ken, just before you leave that, how do you include the derived demand? So as incomes go up and meat consumption goes up, then you have increased derived demand for cereals in the income.
Yeah, that's a good point. Yeah, I'm sure that's an important point. I only get it indirectly here. It's the cereals embedded in the meat that the households spend their money on. So, yeah, the derived demands, they're behind the scene. So this is expenditure just by households. So those derived demands are not measured directly, but they get indirectly when they hit households.
So this is measured at the household level rather than the farm gate?
Correct, yeah. Okay, so we can measure diversity of these across these N items of consumption, measure the diversity of the shares by taking a weighted logarithmic variance. So here's the weighted mean of the shares, log W bar I call it. It's the negative entropy of the distribution of the shares. Deviate the log of the ith share from the average, square it, weight it by the share, and then just add it up over the N items in the budget. And I call that the variance of the budget shares, pi sub W, and measures the dispersion of the shares, obviously. So it's a cross-commodity variance of the shares. And we've got analogous measures for the cross-commodity variance of the prices, quantities, and then the price-quantity covariance. And those second-order moments, those weighted second-order moments, satisfy this identity that the variance of the shares is made up of the sum of the variance of the prices, the quantities, and twice the price-quantity covariance. So if we want to look at the diversity with respect to nutrition, we should split out the price component of the variance of the shares and just look at the variance of the quantity. So the quantity variance is what I'm going to look at right now. Pi sub q, it's the variance, logarithmic variance of the quantities. So that's that guy up there on the vertical axis, plot it against the log of income, and it slopes down. The quantity variance falls as we get higher income. So we get more diversity. Lower variance means more diversity of the quantity component of the budget as income goes up, this variance falls. The elasticity here, that's a semi-elasticity, the coefficient of log income there, and the elasticity varies from about 0.5 to 0.2. Next thing that we can do is to divide up these N goods into these G groups, and we can get that the total quantity variance can be decomposed into a between group component and a within group component. And if we do that for these same groups that we had before, we can look at the inequality of diversity. The inequality of diversity in the following sense. This number up here, 2.4, tells us that the diets of the rich countries, that is, countries in the first quartile, first income quartile of those 155 countries, the diets of the rich countries are about 2.5 times as diverse as those in the poor. If we use the total variance of the quantities. But if we use this between component, just concentrate on those broad groups, those 7 broad groups, we see that this inequality goes up substantially from 2.5 to 3 1/3. So that's 3 1/3 diets of the rich countries, 3 1/3 times as diverse as those in the poor. So the conclusion is that if we just focus on the total budget and ignore this between-within component, then we're going to mask a substantial amount of the inequality of diet diversity between rich countries and poor countries. Okay, all serious shoppers know the difference between fillet steak and rump steak. The source of my research material here is Woolies Subiaco. All serious shoppers know that fillet steak not only tastes better than rump steak, costs more. It's about twice as expensive. It costs about, that's $38 a kilo fillet steak versus $19 a kilo rump steak. So it's about twice as expensive, the fillet steak. So fillet steak, it tastes better, probably has less fat, probably more nutritious than rump steak, and it's clear that it's better. It's clear that it's got higher quality. But if we think about quality for just a few moments, in many, perhaps most cases, quality becomes much less clear-cut. Exactly what is quality? How do we compare the quality of services, of different services? Like, how would we compare the quality of, say, a restaurant meal with the quality of some medical service? You're comparing apples with oranges, and even comparing the quality of, say, medical services over time. It's not easy, although they have probably improved with keyhole surgery to have your appendix out. Now you have a little incision, whereas in the old days it used to be, you know, a 10 centimetre wound that you'd have. How would you measure the quality improvement in medical services? It's not easy. So quality, I say here, it's difficult both in principle and in practice. There's considerable elements of subjectivity involved in measuring quality once we get away from the really easy products like rump and fillet steak. And someone famous said this: a commodity is a queer thing, abounding in metaphysical subtleties and theological niceties. Anyone know who said this? It was Karl Marx. Does Karl Marx? Yeah, right. It sort of got his hallmarks. You know, you're thinking, what the hell does this mean? So it was Marx, and Marx's big buddy, his financier, was Engles, not related to Engel. So quality and its consequences, these substantial improvements in quality, we've got to take them into account to measure inflation because we want to have the pure price effect for measuring inflation. If we don't, we're going to overstate inflation. The ABS say that the CPI inflation is overstated by about 0.5 percentage point per year because of the inadequate accounting for quality improvements. So if we overstate prices, we're going to understate volumes. So GDP is going to be understated if prices in general are overstated because of the neglect of quality improvement. And there are a lot of ways of trying to adjust for quality right now. The price of the product, hedonic pricing is probably the dominant way of adjusting for quality now. Statistical agencies around the world use some hedonics, but they're a little bit reluctant to do so. Still, they have other ways of measuring quality, the matched model approach, package size adjustments. The price of a package increases by X%, while the volume of the package increases by Y%. They say that the price increase is X minus Y%. And they use hedonics quite extensively for pricing computers these days, a bit on cars too. But these approaches aren't completely satisfactory. There's subjectivity involved in declaring what is quality, what's good for the quality. In hedonic models, you've got to have those characteristics, you've got to say what they are. There's problems about existence of constant quality models. They might have disappeared sometime. They may no longer exist, I mean to say. Then there's always the problem of hard to measure services, and how do we measure the quality of the basket as a whole. Okay, we could skip over that. Let's go back to Chad, and let's look more closely at the food that this family consumes. It's pretty bland and moderately unprocessed stuff. We've got these grains and probably some nuts down here, maybe some lemons, a bottle of water. Contrast that with this picture here, very colourful. We've got all this fruit up here, these vegetables here, all these packaged foods down here, Coca-Cola here, AC/DC t-shirt up here. I don't think we've got time for me to tell you the link between AC/DC and the Faculty of Economics and Commerce. There is a link, though, maybe in question time. But so we see more diversity, but more colourful food, and in some sense, it's obvious that the food is of higher quality in Norway than in Chad. It looks tastier. Maybe it's more nutritious too. So what's different? The volume of food is very different. The number of food items is very different. So is the nature of what's eaten in Chad versus Norway. The Norwegian food is more processed, it's more packaged, it's more colourful, maybe it's more tasty, and maybe it's more healthy. So let's consider two countries, country C and country D. And here's the consumption pattern in country C. And there's the corresponding consumption pattern in country D. Let's compare consumption of each of those goods by the log ratio. And then we've got the budget shares of these N commodities in country C, same in country D. And to compare the two countries, it would be desirable if we could avoid having one country as a base, because that would be asymmetric. It would be desirable if we could have sort of a more neutral way of comparing them. Here's the neutral way of comparing them. Take the share midway between the two. So take the average of the budget share in country C and country D and call that WICD. To compare incomes or the volumes of consumption in the two countries, let's take a Divisier index using this average share as the weight and have that hitting relative consumption, and then we add over all items in the budget. So log QCD measures the volume of consumption in country C relative to country D. Okay, I say let's declare above average quality of a commodity if it's a luxury. So if it's A to I, income elasticity for commodity I is greater than 1, it's above average quality. So more precisely, good I contributes to the quality of the basket if, first of all, it's a luxury, and then second of all, if its consumption in country C relative to D is greater than average, log QCD. So we use these products. The deviation of the income elasticity from 1, so that thing in brackets is going to be positive if it's a luxury. That hit relative consumption in square brackets. If that whole thing is positive, then commodity I contributes to the quality of the basket in country C relative to country D. So because we've got n of these commodities, we just take a weighted average of those terms using those mid-country budget shares, WICD, as weights. So this is a measure of quality. YQCD, quality of consumption in country C relative to country D. And if we look at this expression, it's a weighted average, it's a weighted covariance of the income elasticities, because income elasticities have a weighted mean of 1. It's a weighted average, it's a weighted covariance of the income elasticities and consumption. So if consumption in moving from country D to country C moves in the direction of luxuries, then this whole thing is going to be positive, and we'll be measuring a positive value for quality in country C relative to country D. So it's a weighted covariance of the income elasticities and the quantities consumed. So that's what I say here. When the composition of consumption moves in the direction of more luxuries on average, then quality improves. Same if we move away from necessities. So using the income elasticity as a measure of quality, that gets away from some of the subjectivity attached to these other measures of other ways of measuring quality. So I describe this as a reveal preference way of measuring quality. And, okay, let's skip that. So the advantages of this measure of quality is that it's objective as compared to the hedonic methods, or maybe a little bit less subjective. You can apply it to all types of goods, all goods and services, not just those with clearly identifiable physical characteristics, and it's comparable across goods. You could apply it to the whole budget. It's got some disadvantages, of course. You need the values, the income elasticities, to implement it, and some of the goods that I declare as high quality, high income elasticity, they might have some downside in consumption with them. If we think about high-priced spirits, for example, have a high income elasticity, drink too much of that, it's bad for you, it's going to make you sick or might even kill you if you drink too much of it. So high quality doesn't necessarily mean good for you. I have some income elasticities for those 31 commodities.
So could you skip, so in all of this, it's always the conditional income elasticity,
Yeah.
or you want?
Yeah, it's
Okay.
conditional within food, so weighted average of those things is equal to 1.
Yeah, okay.
Okay, so here's a plot of the quality index against income, and it slopes up. It has an income, it slopes up, but the response of quality to higher income isn't all that fantastic. This is an elasticity multiplied by 100. So the elasticity is 0.12, so a 10% increase in income leads to only a 1% increase in quality. So quality rises, but it's not easy to increase quality. You need lots of higher income to increase the quality of your consumption basket. There's a dual price equality too, which is a weighted covariance of the income elasticities and the relative prices now, and that slopes down. So if you want to know where to shop for your higher quality commodities, you go to higher income countries. So if you want to buy expensive handbags or other branded commodities, you go to London or New York to buy those things. They're cheaper in these higher income countries, but the slope of this thing is pretty small. It's significantly negative, but it's small. And that's what I think all I have to say. Yeah, that's it. Thank you.